have another previous problem from the topic applications of derivatives. So here how it goes is, you have a function f of x equals to tan inverse of sin x plus cos x, or tan inverse of this function, right? You have a function given and it is asked, when is this function an increasing function? Like there are 4 intervals given in the options. In which of these intervals is the function increasing? So first of all, let's understand what do you mean by an increasing function. An increasing function is a function whose graph is something like this, right? Something like this. What does this graph say? It says, as my x keeps on increasing, x1, x2, x3, some x4, right? Then the y keeps on increasing for the corresponding x. That means this is y1, y2, y3, y4. So if your x4 is greater than x3, then the corresponding y4 will have a greater height than y3. That is what increasing function means. That means if I keep increasing my input, my output also should increase, right? And in such a case, when is the function increasing? If you can look closely into the graph, right? When is it increasing? If it's increasing like this, so this is not properly an increasing function, I would say. Forget about this. Look at this graph. This is a sort of an increasing function. So if you see at this point, if this is theta, and at this point, this is beta. Which of the following is which of the two is greater, beta or theta? Beta is greater, right? So as you keep moving ahead, the derivative also is positive. The derivative has to be positive, right? The derivative has to be positive. Only if the curve takes a turn, right? Only if it tends to decrease, derivative will change sign. That means I will say a function is increasing. If a function is increasing, if its derivative is greater than 0, right? So indirectly the answer that they're looking for is, or the question that they have framed is asking you to check for which of the following intervals will the derivative of this function be positive, right? So let's first find the derivative of this function, f dash x. It's nothing but tan inverse of, so you have tan inverse of a function. So first of all you, differentiate the tan inverse function. So that is 1 by sin x plus cos x whole square. And then you differentiate the function inside, right? So that is sin x derivative is cos x and cos x derivative is sin x, right? This is your function, right? Now, as you guys already know, if you look at this quantity is squared, right? So I can write f dash x as 1 by 1 plus sin x plus cos x square. So this quantity squared, this into cos x minus sin x. So this part is always positive. This part is always positive, right? Because it is 1 by 1 plus something which is squared. The minimum value that this will take is 0, right? It can't take a negative value, this squared quantity. So for me, this is not a problem. I need to find the interval. In which this quantity will be positive, because this is positive. If this is positive, only then the product will be positive, right? So in fact, I'm looking for that interval in which my cos x is greater than sin x, right? So you can actually verify that from the options too. But if we go in a systematic manner, how we can actually do this is, you can multiply and divide this function by root 2, right? So you can divide this by root 2 and multiply this by root 2. So your root 2 will be multiplied to both, right? So indirectly what I'm telling is, divide this by root 2 and multiply with root 2 inside. I can write this as sine of pi by 4 cos x minus cos of pi by 4 sin x, right? So this is sin a plus b formula, or cos a plus b, whatever you like to use. So I'll use sin a plus b, where my a is this, b is this, sin a cos b plus cos a sin b, right? So this is nothing but 1 by root 2 into sine of pi by 4 plus x, right? Pi by 4 plus x. So indirectly, what you want is, you want your x to be such that pi by 4 plus x should be positive, right? Pi by 4 plus x, and should not just even be positive, it should it should make the entire sine function positive, right? It should make the entire sine function positive. So I've put a plus here. In fact, it should be minus, right? Because there's a minus in the middle. So it's sine of pi by 4 minus x. So I hope you have realized all of the problem is just down to this function. This has to be positive. I want this to be positive in any of these 4. Like which of these 4 intervals make this function positive? That is the question, right? So sine x is positive, sine of anything is positive either in the first quadrant, right, either in the first quadrant or in the second quadrant, right, from here to here. So whatever this quantity is, this quantity should lie between, in fact don't include equality, because your function has to be increasing, right, it has to be strictly increasing, and also at the endpoints they have not included the endpoints, so I won't include the endpoints, I'll exclude them, and you need to start from 0, and you can go up to pi, right. Now when you subtract with pi by 4, so you subtracted with pi by 4 here, less than, subtracted with pi by 4, minus x less than, subtract this with pi by 4, so this is nothing but pi by 4, this is 3 pi by 4, right. Now this is how minus x is, right. But remember, whenever you have a negative quantity, it's always better to write it like this, minus x less than 0 and 0 greater than minus x less than 3 pi by 4. Or you could also leave it, this is not a fractional case, so just multiply with negative on minus 1 on both sides. So pi by 4 less than x less than minus 3 pi by 4. Why did I reverse the inequalities? When you multiply with minus 1, you're supposed to reverse the inequalities. So look at this now, look at this. This interval starts from pi by 4, and goes to pi by 2, right. But your x should be less than pi by 4. It should start from minus 3 by 4 and it can go to pi by 4. So this is obviously not the answer. Look at this. This is minus pi by 2, right. This is minus 3 pi by 4 is minus 135 degrees, and this is minus 90 degrees, right. So this is obviously included. The lower limit is obviously inside the interval and it goes up to pi by 4. So this can be the answer, right. This can be the answer. Let's look at this. Is this valid? No, because your x is not allowed to increase pi by 4, increase from pi by 4, right. But here you'll have some value pi by 4 to pi by 2 inside this interval, and your x is not supposed to increase. So you can't take this, and similarly for the same reason you can't take this also. So this is the answer.